So this is a kind of graph we didn't really look at in class, so we just got to scratch our head and think about this, right? Notice that no current flows at 1.15, right? So with the violet light, with this 400 nanometer light that they're using, the 1.15, that must be the cutoff, right? That's the stopping potential. Which is, by the way, the stopping potential is also, okay, the stopping potential is also the kinetic energy. We can say those electrons have an energy of the kinetic energy max, right, is 1.15 electron volts, right? Okay, so there it is, and so it's going to have the same. If we have an increased intensity, it's going to have the same cutoff because the photons themselves won't have more energy, right? The energy depends only on the color, and they didn't change the color, right? So let's start here, and then I believe what happens is this is called the saturation current, okay? For a given intensity, there's a certain current, and at the saturation level, every photon is liberating an electron that makes it across, okay? For these voltages, not all the electrons make it across, okay? Because some of the energy randomly goes to thermal energy. So even though you have enough to get some across, you don't get them all across. But at some at some potential here, right, we actually get them all across. So a higher intensity is going to have a higher line here, right? And then it's going to always be above this one, and then just kind of make it go down like that, right? Okay. So that's this part here, right? And then to figure out this part, what we're going to do is we're going to, and we'll do everything in electron volts. We'll just use the concept of the photon energy, okay, equals work to remove it plus kinetic energy, the max kinetic energy, okay? So the photon energy, let's figure that out, right? Use E is hc over lambda, right? There's your lambda. You can actually use the version of hc that is, they've got hc all wrapped up, so 1.24 times 10 to the minus 6 electron volt meters, right? And that'll give you the energy. Put that here, okay? Well, okay, that equals the work function plus, and then of course our max kinetic energy is that 1.15 volts. Do everything in electron volts. So figure out the photon energy in electron volts, put it here. And then the work function is just a matter of subtracting, okay? What's interesting to me is that in the Mark scheme, they actually use the values for, they use the values of H and C, and they don't use this combined one, and they arrive at a slightly different answer than I arrived at. But I'm assuming the markers would allow 1 part in 1,000 difference. Okay. Happy hunting.